Good morning. This is your stats sensei, Mr. Spensei, and we're going to do an exit ticket on the normal distribution and combining normal and central limit theorem. Suppose the mean and room and board expenses per year at a certain four-year college is $7,850. So we know that that's important. So our mean is 7,850. You randomly select 9 dorms offering room and board near the college. Assume that the room and board expenses are normally distributed. That means because they're normally distributed, we don't need to worry about sample size with a standard deviation of 1125. What is the probability that a random dorm has room and board of less than 8,180? Well, in this case, we're dealing with one random dorm. So in this case, central limit theorem does not apply. So central limit theorem doesn't apply. This is just going to be a normal. So let's go ahead and draw our picture. All right, our mean is 7,850. And less than 8,180. Well, 8,180 is over, but it says less than. All right. So we're going to negative infinity. And once again, this is the normal CDF because we're only dealing with one, a sample size of one. So norm CDF, the lower bound, negative infinity, the upper bound, 8,180. The mean is 7,850. And our standard deviation is 1125. All right. Lower, upper, mean, standard deviation. Lower, upper, 7,850 is our mean, and 1125 is our standard deviation. We're going to the calculator, and we're going to go second vars, normal CDF. So second vars, normal CDF. Try that again, second vars, normal CDF. All right, our lower bound, negative infinity, negative 9, caret 99. Upper bound, 7,850. Mean, our upper bound is 8,180. Our mean is 7,850. I made those, I switched that on accident. And then 1125 is our standard deviation. So 1125. So let's check that again. So negative infinity, upper bound of 8,180. That's where our shading stopped. Our mean is 7,850. And our standard deviation is 1,125. Press enter a couple times, and we find out that yes, it's over 50% because we are over halfway, and it's 0.6153. 0.6153 or 61%. Once again, make sure you show you the graph, calculator commands, and the actual probability. What's the probability that the mean? Oh, this tells me mean. So we're working with the sampling distribution of the means. So this will be central limit theorem of the 9 dorms. So there's my sample size. My sample size is 9. All right. Is less than 8,180. So once again, we actually can use exactly the same drawing. It's not changing because 7,850. This is 8,180. And we're shading less than, so we're shading to negative infinity. But our standard deviation is going to change because up here it was 1125. And here, because we're working with the standard deviation of the population, here we're working with the standard deviation of the sample mean, which has the formula standard deviation of the pop divided by the square root of n. So we're going to go to a different part of the calculator. We're going to go to z-test, which you need to write down, and it's going to ask you for the mean. That's the first thing it'll ask for, 7,850. Then it's going to ask you for the standard deviation. And they're asking for the standard deviation of the pop. And the standard deviation of the population was 1125, 1,125. Then it's going to ask you for the X bar, which in this case is 8,180. And then it's going to ask you for the sample size, which is 9. And then lastly, it's going to ask you for the direction you're shading, which happens to be a less than because we're shading to the left. So stat, test, z-test. 7,850 is our mean, 1125. Our X bar in this case is 8180. Our sample size is 9. And we want to make sure we have the less than. Once you highlight it, press enter, drop down, and we want to calculate. And we find out that it's 0.81, so much greater percentage chance than what we had before. Why? A group of 9, 0.8105. All right. What's the probability of the mean cost? So once again, we're talking about the mean. So this is probably central limit theorem, standard deviation of the mean, sampling distribution of the means. But instead of using 9, we're going to have a sample size 4. And they want to know the probability that it costs more than 7,250. So since we're working with the central limit theorem, we're going to go to the stat test, z-test, and we can go ahead and use 4 just like we could use 9 because up above they told us it was normally distributed. If it hadn't been normally distributed, we would have had to have a sample size of 30 or more. So mean is 7,850. And here we're looking for 7,250, which is below it. And we're going to shade up because it said more. So once again, a z-test. The mean is 7,850. Our standard deviation is 1125. Our X bar is 7,250, and we need a greater than symbol. So that's the work that we need to show in order to receive credit. And we're going to go stat, test, z-test, press enter. 7,850 is our mean, 1125. Our X bar is 7,250. Oops. Stat, test, back in there. Our sample size changed from 9 to 4, and we changed the direction. We're shading up. And when we do that, we find that our probability is 0.8569. So probability is 0.8569. All right, appreciate you watching. That concludes this one, and I hope to see you on the next one.